Ever wondered what really causes an electric shock and how to protect yourself? Let's dive into the shocking truth why voltage isn't the whole story and how you can stay safe. I'm Masoud the Electrician and welcome to the channel. Does high voltage always result in electric shock? Not necessarily. High voltage increases the potential for a shock, but it's the current, the flow of electricity that determines how severe the shock will be. Voltage can be thought of as the force pushing the electricity, while current is the actual flow of electrons. Think of voltage like water pressure and current like the flow of water through a pipe. It's the flow that can cause harm, not just the pressure. The body's resistance plays a big role here. Dry skin has high resistance, but wet skin can lower resistance significantly, allowing more current to flow. This is why working with electricity in wet conditions is much more dangerous. Water lowers your resistance and allows more current to flow, making even low voltages hazardous. Even something as low as 50 volts can give you a significant shock if you're handling it with wet hands. This is why working with electricity in wet conditions is so risky. Water lowers your resistance and allows more current to flow, making it far more dangerous. How many volts are enough to cause a harm? The answer is that even low voltages, such as 30 volts, can be dangerous under the right conditions. For example, if you have a wound or broken skin, electricity can enter your bloodstream more easily, potentially affecting vital organs like the heart. This makes even seemingly harmless levels of voltage risky in certain situations. Our skin usually provides a protective barrier, but internal tissues like blood and muscles have much lower resistance. This is why exposed or damaged skin significantly increases the danger. What about 230 volts? The standard household voltage in many places. Surprisingly, it isn't always lethal. Factors like wearing safety shoes or standing on an insulating surface such as a carpet or wooden floor can reduce the risk. These conditions limit the current flow through your body, making it less likely to cause harm. So, does this mean we can safely touch 230 volts? Absolutely not, but it shows just how much depends on the circumstances. Always ensure your tools and protective gear are in good condition. A small crack in an insulating glove or a damp carpet can change the situation entirely. Thousands of volts might not always be dangerous if the current is very low. A good example of this is static electricity. When you touch a doorknob and feel that small zap, it's caused by thousands of volts, but the current is so minimal that it doesn't harm you. Static discharge can still be dangerous in certain environments, like near flammable gases or sensitive electronics, where even a small spark can cause big problems. For electricity to cause harm, it has to pass through your body in a way that affects critical tissues. The heart is particularly vulnerable because electricity can interface with its rhythm. In controlled settings, such as hospitals, electric shock treatments are carefully applied to ensure the current passes through the heart in a specific way. If you touch two wires like 230 volts and neutral with one arm, it's more likely to cause localized skin damage. However, if electricity finds a path through your bloodstream, it can reach your heart. Blood, being conductive due to its salts, creates a path of low resistance. When electricity flows through the body, it causes the muscles to contract involuntarily. In extreme cases, this can prevent the person from releasing the source of the shock, leading to prolonged exposure. This is one of the reasons why electric shock can be so dangerous. It's not just the initial contact, but the inability to break free from the source of the current that makes it more lethal. How can we protect ourselves? One of the most effective devices is the residual current device, or RCD. RCDs monitor the current flowing into and out of a circuit. If there's a mismatch, such as current leaking through a person, the RCD disconnects the power almost immediately. These devices are designed to trip when they detect a leakage current of 30 milliamps or more, which is considered the safety threshold for homes. One last tip. Your RCD has a test button. Pressing it simulates a fault and ensures the device trips properly. This should be done regularly, at least once every 6 months. Why not check yours after watching this video? It's a simple step that could save lives. To summarize, electric shock depends on voltage, current, and the path electricity takes through your body. Always prioritize safety by using protective gear and testing your RCDs regularly. If you found this useful, hit like and don't forget to subscribe for more tips. Electricity is powerful. Stay safe and be cautious when working with it.